Hello everyone, welcome back to my channel. My name is Piyush. In this video, I have brought to you an amazing project which is a beginner level project written in Python, and it is powered by OpenAI GPT-3.5, which is a large language model or an LLM, and backed by Apache Cassandra database. In fact, we are using a better version of Apache Cassandra. We are using a managed service which is provided by DataStax, and it's called Astra DB. It's built on Apache Cassandra, which is vector database used for retrieving and storing results in the database, and you get the response in near real time. It's really fast, it scales rapidly. We'll talk more about it, like why we are using it, but for now just understand like this is what we're gonna do. So this is a chat based interactive game in which we provide certain inputs to the game, and based on that it will provide you the next steps, and based on our next input it will guide you whether you are going in right direction, or it will provide you certain outcomes. As I have mentioned, this is a beginner level project. I'll make sure to include every resource that I have used in implementing this project. I will share every little detail in the GitHub repository that I have created, including the architectural diagram, the source code, and all the useful URLs that you can refer. And that being said, let's head over to the GitHub repository and let's start working on it. So I have logged into my GitHub repository. Link of this repository will be there in the description section of this video, so do not worry about it. If you scroll down, you will see an architectural diagram. So let's quickly spend a few minutes on this to explain what we are going to do. So a user starts working on a template which instructs the AI about the context of the game. It includes the user role and acts as a guide for the player to achieve certain objective. Right? In this case, it will guide the explorer to find the galaxy star. This will have all those details, and then there will be a detailed prompt. This prompt will have the details of the data about how to retrieve the data from large language models such as GPT-3.5, and with the help of this Python code, it will make the API request to GPT-3.5, and it will return the response back to the user as the response from API. It also creates a connection with the database, Astra DB in this case, which will store the chat history of the user, of the entire conversation that we are having with the AI model, and based on that it will also provide you the next output from their side. And retrieving chat history from a vector database will be really fast. That's why we are using this particular database in this case. Had it not been a real-time interactive game, you would have used a NoSQL database such as MongoDB. But NoSQL databases are not really powerful in use cases such as AI agents, generative AI, or anything to do with the AI ML. In that case, we have to use really powerful database such as Apache Cassandra, which is a vector database, and that's why we are using Apache Cassandra, and we are using Astra DB, which is the managed service of Apache Cassandra, so that you don't have to worry about the infrastructure, you don't have to worry about setting it up, all the operational tasks, it will be taken care by you. And the good thing is you can start without paying any single penny. You don't even have to write your credit card information while signing it up. You can start using it right away. We'll show you how to set it up. It's simple, it is super easy, so we'll get to that. So this is how it will retrieve the response with the help of the code that we'll be writing, and based on that it will return the response to the user, and it will do that in a while loop, and once it reaches and once it gets a certain keyword such as end, the end, it will then end the game, and it will prompt the user that your quest has ended, or you have won the game or you have lost the game, something like that. We'll see about that. Right, so let's scroll down to the page where it says prerequisite, and let's start working on it. So it says you need to have at least Python 3.7 or higher version. You need to create an OpenAI API key, and you need to create DataStax Astra database, which is a Cassandra database. So we'll do that one by one. First of all, like I already have Python installed, so I'm gonna install the dependencies using this command. Just copy it here. If you are using Mac or Linux, you can just directly do that in your terminal window. But if you are using Windows, you can use the internal built-in terminal from the VS Code. So let me go back. And on the right side, I have my terminal window. So let me just quickly install the dependencies. I have already copied the command up there. So pip install Cassandra driver, OpenAI, and LangChain. Enter. Okay, I'm gonna pause the recording till it's doing its work. Okay, looks like it's done. Now let me just clear the screen. The next step is to create the API key from OpenAI. So you have to go over here, platform.openai.com. Have already signed up. So it's simple, straightforward sign up. And then from the left side where it says API keys, you just click over there and create a new secret key. Give it a name. So let's call it demo my key. Okay, create secret key. And you can just copy it from here, else it will be gone after this. So you have to regenerate the key. So let me just keep it open and then let me proceed further to the next step. The next step is create the Astra DB key space. So I have to go over here where it says datastacks.com. Again, I'll provide all the links in the GitHub repository. So it provides you all the details like what this product is all about and why do we use it. I have already explained you a little bit, and rest you'll get to know by going to this particular page. So just click over here where it says try for free, and as I mentioned, you don't have to enter your credit card details or anything. It will be simple and straightforward sign up. Okay. So let me sign up with Google. Okay, it says get a verification email. So click send me an email, and it will ask you to verify the email or enter the verification code over here. So let me enter the verification code. That's pretty much it. Now go on the left side where it says databases, click on that and hit create database. Okay. Now there are two options, vector database and non-vector database. Non-vector database is mostly the serverless traditional database solution, but what we need is this one. Now give it a name, database name. Let's call it demo-𝗙𝗃. Okay, and then key space name. So these two names we'll be using in our Python code. So make sure to remember this. Key space name would be my database. Okay, and then provider, like where do you actually host the instance of this particular Astra database, right? You have three options to choose from: Google Cloud, AWS, or Azure. Let me choose Google Cloud, and you can select the region. So this is the only region available. So I'll just select it and hit create database. So it still says the database is in pending state. It will take few minutes for the database to be provisioned. But let's go ahead over here where it says connect. Click over here, and basically we have to download the bundle. Scroll down and select the type of app that you are working with. So in our case, the driver is Python. Select this. Now it has certain prerequisites, like you download the bundle, create the application token, install the dependencies. We have already installed this, and then create a database connection. So we'll copy the code from here, but for now let's go up and hit download bundle. Right, select a region and download secure bundle from here. Okay, so the bundle has been downloaded. So I'm just gonna move that in the same folder where our VS Code was initialized. All right, I have copied it over here. Now as part of the next step, I have to generate an application token. So click over here, generate the token and download token details. Again, place this file in the same directory. So I'll just copy it. I'll just download this. This is a JSON file which has client ID, client secret and token. So we'll just load this JSON file in our Python code so that we don't have to replace the secret and the client ID over here. We'll just copy this as well. Okay, I have copied the JSON file as well, which has the secret key and credentials. Now it says pip install Cassandra driver. We have already done that. And now let's go ahead and create the database connection. It's asking to create a separate file for connect database, but we'll use the same file. So I'll just copy the code from here, right? And this will be our starting point. I'm gonna go ahead over here and write a file, tutorial.py, okay, and paste the details. Okay, now if you see, it has certain imports already, and these imports will import the necessary libraries for working with Cassandra database, with large language model, with JSON and so on. We'll add some more as well. And over here are the details of our cloud config. It will have the configuration details, it will have the secrets and everything. And this file over here, so I'll just replace this file with the one that we have downloaded. So over here, rename and copy, go back and change this to demo-𝗔𝗃-token. So what it will do is it will load this file and it will extract client ID and client secret from it. So this is what we needed, and we already have the cloud config, which is in the same path, and the name is same, secure connect demo-𝗃.zip. So keep it zip, do not extract it, it will load the file automatically. Okay, now let's go ahead and see if it is able to get the connection from the database. But before that, we have to add two more variables over here. Astra DB key space, so Astra DB space, this is the key space that we have generated. Let's go back and over here, go to overview. Key space name is my database. I'll just copy it from here and paste it over here. Now the next one is OpenAI API key. So this is the key that we generated from platform.openai.com. So I'll go back, copy and paste. Ideally you should not share it with anyone, but I'm gonna delete the key after this demo, so fine for now. Now I'm gonna add a few more imports to download the dependencies for Cassandra, for message history, for OpenAI, and from LangChain for prompt template. And if we go down, now we have to initialize the chat message history to store the conversational data. So I'll go over here and I'll write message history equal to Cassandra chat message history, and then I'll add session ID. So session ID could be like literally anything. So let's add anything, and basically it's used to store the details in a particular session, all the conversation data. And then session is equal to session. Then we also have to add key space, which is the variable that we have already defined, Astra DB key space, and then TTL, which is time to live. So let's keep it 3600. So that means the conversational data will be stored for 60 minutes. Actually this should be TTL seconds, so let's add seconds over here. Now this is done. Now the next part is message.history, message history.clear. I'm gonna clear the message history with this, and then we'll initialize the buffer. As of memory is equal to conversation buffer memory, and inside that we'll add memory key, and let's call it chat history. We'll use this variable later on, and then we'll add chat memory is equal to message history. Now the next part is to add the template, but before that I'm just gonna run this and see if the database connection is successful or not. So I'll save this and I'll go to my terminal window from here, run it. Python 3 tutorial.py. It says invalid syntax, chat memory. I have placed a comma from here. Add it and let's run it again. Okay, so these are some warning messages. So it's basically asking to use a different dependency. That's fine for now. It says could not import Casio Python package. Please install it with pip install Casio. So let me install this as well, and I'll update the README file as well. Pip install Casio. This should be pip3 as I'm in Mac. Okay, now let's run the command again. Okay, now it is printing this message. So when you get any message like this, like a random string, that means the database connection is successful, because this is what we are printing, the release version from the system local, right? And if there had been any other value, if the database connection had some issues, then it would have printed an error occurred, which is not the case. So we are good till now. We have successfully established the connection with Astra DB Cassandra database. So let me clear the screen. Okay. And let's add the template now. We don't need this line of code. So let me just clean it up. And I'm just gonna add the template. It over here. Okay, so let's read what does it says. It says basically these are just the rules that we are defining. This template will have all the details about what to follow, what not to follow, how it will proceed further, and you can play around with these rules over here to make this game more interesting, to make sure that game doesn't end in just like few prompts. You can make this as complex, as hard as possible, right? So for now, you can just read this. I'm not gonna bore you with reading all the narration, but it will just ask you, start by asking the player to choose a type of spacecraft that will be used later in the game. So that will be the first input, and then have few paths that leads to success in finding the star crystal, have some path that lead to failure or danger in the space. If the user faces a critical situation, generate a response that explains the outcome and end in the text the end. I will search for this text to end the game. So whenever the model will find this particular string the end, the game will be ended then and there, right? So it has few paths that will lead to the success and few paths that will lead to the failure. So in either case, whether the user gets the star crystal, that means if he or she won the game, then also the game will be ended, or if he or she has chosen the path which led him or her to the failure, then the game will be ended. So this is how it will proceed further. And this chat history and human input, this is what we have initialized above as memory key. So let's go over here and let's try to write the prompt now. So prompt is equal to prompt template, right? And template will have some input variables, such as chat history, and human input. So these two variables we have already initialized above. Then we have template is equal to template. Okay, and now this is the time we make connection with OpenAI. Okay, so I have completed the code. Now let me just walk you through the entire code. So go up. So here we have some import statements to import all the dependencies from different libraries. Then we have created a color class to make this a little visually appealing while printing anything on the screen. And then we have used 3 print functions to print user input, AI response, and final game results. And these details we copied from the data stack bundle itself. Right? It has secure connect bundle, it has the API token, client ID, client secret, everything. Then we have added 2 variables. One is Astra DB key space. This name is same as when we created the database, and here is an OpenAI API key. Right? Then we have added the message history over here. Then we have initialized the Cassandra buffer over here for storing the message history and to retrieve the message from the buffer itself. Then we have the template which instruct the AI about the context of the game and all the rules that it has to follow, like how to start the game, how to end the game, what is the difficulty level of the game, and so on. And then we are doing the OpenAI model initialization over here with the help of OpenAI API key, and it also uses Cassandra buffer memory. Then we start the game with the choice. This choice is the starting point of the game, and there is a while loop that will keep on asking the input from the user until it receives the end in the response from API, or if the user press Ctrl+C, then the game will be interrupted, and that exception is also being handled over here in this try catch block. Right? So this is the entire code base. Now let me just go to my terminal window and let's run this. So I'll use the same Python 3 tutorial.py. Right? There are some warning messages, so you can ignore this for now. Okay, so here is our first response. Here is our first input. It says, "Welcome to Cosmos Explorer. I am Nova, your guide on this intergalactica journey. We are on a mission to search the legendary star crystal. This is the objective of the game, to find the star crystal in the galaxy. To begin with, please choose a type of spacecraft for your journey. Options are small fighter spacecraft, a medium-sized exploration ship, or a large cargo ship." So let me enter my reply as a large ship. So you can enter anything because the responses will be provided by AI, not from a if-else conditional logic or a switch case statement. It is generated in real time from AI, and then the output or the conversation, this entire conversation, it will be stored in the database and it will be retrieved for a faster response. Now it says, "Excellent choice. A large cargo ship will provide us with plenty of room for supplies. Now let's set our course." Okay, let's go. Okay, now it says, "We set our coordinates and began our journey. After a few days of travel, we come across a strange space station orbiting an unknown planet. There appears to be a beam of energy emitting from it. Do you want to investigate?" "No. Keep traveling." We decided to stay away from the strange station and keep traveling. After a few days of travel, our sensor detected an asteroid field ahead. Do you want to navigate through it? Yes. Let's move. Okay. Now it says, "We navigate through the asteroid field. Suddenly we come across a large asteroid in our path. It appears to be made of strange material and it seems to be blocking our way. Do you try to break through the asteroid, or do you want to find an alternative route?" So find an alternative route. Okay, so now it says, "We quickly search for an alternative route and eventually find a path around the asteroid. We continue our journey and eventually come across a bright light in the distance. So we found a star crystal." And it says the end. So as soon as it found the end, it will end the game with the results. And it says the adventure concludes. Thanks for playing. So this is what we have seen. You can run it as many times, and every time you enter something, it will provide you a different response. So that's the beauty of it. That's why we are using this technology stacks and everything. So that's it for this video, and I hope this video was somewhat helpful in understanding how it works, like why do we use it, like all the things, how do we integrate large language model with the vector database such as Astra DB, and what are the benefits of using it. So if you have done this, I have a small task for you. Why don't you create this project and then dockerize this file and deploy it on cloud. Choose the cloud of your choice and share with me your progress on LinkedIn, Twitter, whichever social media platform you are using, and let me know in the comment section below if you face any issues in implementing this project, or if you liked it, then also give it a thumbs up and subscribe the channel if you are new here. So thank you so much for watching. I will see you soon with the next video.